this second lesson on Chapter 8 of Mechanics, we're going to have a look at using calculus. Now this is something that we used in the Year 12 content, and we can use differentiation and integration to help us go between distance, velocity and acceleration. Now in Year 2 we can do this, but we can do it with obviously more complicated things to differentiate and integrate that you've learned how to do this year, but also combining it with vectors, which is actually quite straightforward. We just kind of do the differentiating to the top and the bottom at once. So just to remind you, maybe kind of using this diagram here, if we differentiate displacement, so the rate of change of displacement, that is velocity, and your rate of change of velocity, that is acceleration. And then we can integrate to go the other way, okay, or the area underneath the graph. We know that the area under a VT graph gives you displacement, for example. Okay. Here's our first example for a question of this type. So a particle is moving on a straight line with an acceleration of cos 2 pi t meters per second squared. The velocity at t equals 0, so the initial velocity is 1 over 2 pi meters per second. And we've got to find an expression for the velocity at time t. So to go from an acceleration to a velocity, we need to integrate it. So that's what we're going to do. So we need to integrate the acceleration with respect to time, and that will give us the velocity. So we're going to integrate cos 2 pi t dt. So when I integrate cos, I get sine. So I'll get sine 2 pi t. But if you remember from when we've done integration previously, I also need to divide by the differential of this bit here. So I need to divide by 2 pi. So I'm going to get 1 over 2 pi in front of it there. And then plus c. And that is my velocity. Now I also need to use this extra bit of information. They've told us when t is 0, the velocity is 1 over 2 pi. So I can fill that in to find c. So the velocity is 1 over 2 pi when t is 0. Okay, so this is obviously going to become sine 0, which is just 0. So this whole term here becomes 0. So c is just 1 over 2 pi. So my full equation for the velocity is 1 over 2 pi sine 2 pi t plus, not plus c, plus 1 over 2 pi. There we go. Now the second part says what is the maximum speed? Okay. So the maximum speed, there's a couple of different ways you could go about doing this. Basically what we want is what is the maximum value that this function here can take, okay, the maximum v. Well, the only thing that can change in here really is this trig bit here, sine 2 pi t. The maximum that sine 2 pi t can be is just 1, okay. So I'm going to make a note of that here. The max of sine 2 pi t is 1. So that's the biggest that could be, because this is just a squash of 2 pi to a sine graph, so the maximum is still 1. So the maximum velocity, if I call it v max, would be 1 over 2 pi times 1 plus 1 over 2 pi. So that's just going to give me 1 over pi. Okay, meters per second, or you could work out as a decimal if you preferred. As an alternate way of doing this, now kind of the formal way in which we find a maximum is we differentiate it, right? We differentiate it and set it equal to 0 to find a stationary point. So I could differentiate this, but actually we know what we're going to get. We're going to get the acceleration, which was cos 2 pi t. So we're looking for when a is 0, okay, or when the derivative of this is 0 to find a stationary point. Another interpretation of that is your maximum speed is when you can't actually get any faster. And if you can't get any faster, then your acceleration would obviously be 0. So I could take my acceleration, which is cos 2 pi t, and set it equal to 0. If we solve that, our first solution is t equals a quarter. And then I could put that back into the velocity expression to find out what is the velocity at that point. So I'd get 1 over 2 pi sine 2 pi times 1/4 plus 1 over 2 pi. And if you work that out, then you still get 1 over pi as your answer. So either of those methods would work. Now for part C, the distance travelled in the first 3 seconds. Okay, so the distance travelled in the first 3 seconds. So to find a distance or a displacement, we have to integrate or find the area underneath the velocity. So we want to integrate the velocity with respect to time in the first 3 seconds. So that's between 0 and 3 for t. Okay. So let's fill in what v was. So v was 1 over 2 pi sine 2 pi t plus 1 over 2 pi dt. I'm actually going to factor out this 1 over 2 pi just to make things easier. So I'm going to put the 1 over 2 pi at the front. If you don't do that, you will obviously still get the same final answer. But I think doing it like this just makes this a nicer expression to integrate. So I've got 1 over 2 pi. Now to integrate this, I'm going to get sine, that integrates to negative cosine. So I'm going to get negative cos 2 pi t, and I also need to divide by the differential of this, so I need to divide by 2 pi. And if I integrate 1, then I get t. And it's still between 3 and 0, then I just need to substitute my limits in. So I've got 1 over 2 pi times my first bracket, when I substitute 3 into here, okay, now I'm going to get the trig bit here becomes just 1, so cos 2 pi times 3, that's cos 6 pi, which is just 1. So I'm just going to get minus 1 over 2 pi times 1 plus t, so that's plus 3. The second bracket, I substitute 0 in, I'll get cos 0, which is 1. So I'm going to get minus 1 over 2 pi plus 0. Okay. Now if we just sort out what's inside this bracket, well, I've got minus 1 over 2 pi minus 1 over 2 pi, so it becomes 0. So I've actually just got 3. So my final answer is 3 over 2 pi meters, or as a decimal, that is 0.477 meters. Okay, there we are. Now in an exam, depending on how the question is phrased, you may or may not have to do the integration manually. If it just says basically find the answer, then you could actually type in this integral here into your calculator and get the decimal answer out here. Obviously, if they say show that it's 3 over 2 pi, you're probably going to have to do it manually because your calculator won't give you that, it will give you a decimal. If the question also says something like you must show your full working, or using full reasoning, or the use of calculator technology is not allowed, or something like that in the question, then obviously you have to show your working. But if it doesn't say anything like that, then you can do it just by using your calculator. And even if it says that you do have to show your full working, you can always use your calculator as a check to check have you actually done this integral correctly or not, which is really useful, so you'll know if you've got it right or not. Here's another example. So we've got a particle of mass 6 kilograms is moving on the positive x-axis, so just moving horizontally. At time t, the displacement s is given by this equation here. If you can't quite read that, I'll just write it a bit bigger. So it says that s is 2t to the 3 over 2 plus 1/3 of e to the minus 2t. Find the velocity when t is 1.5. Okay, so to find the velocity, we need to differentiate the displacement. So that's ds by dt, the rate of change of displacement is velocity. So I need to differentiate this function here. So 3 over 2 times 2, so that's going to give you 3t, and then subtract 1 from this to the half. And I've got minus 2, so I need to times by the differential of this. It's kind of like using the chain rule. I need to times this by minus 2, so that'd be minus 2/3 e to the minus 2t. and then I just need to plug in t equals 1.5. And if you do that, you can just do it. You can type that whole expression with t equals 1.5 into your calculator, and you'll get 3.64 meters per second. Part B, given that the particle is acted on by a single force of a variable magnitude, so basically there's a force pushing it which can change, which acts in the positive x-axis, so basically in the same direction it's moving, find the value of f when t is 2. So we've got to find a force, but we've only got displacement and velocity. Well, the thing that we can use to link these together is f equals ma. Okay, I can find out what a is, and I know what the mass is already. So to find a, the acceleration, that is the rate of change of velocity. So I'm going to have to differentiate this velocity expression here. So half times 3, so that'll be 3 over 2 t to the minus a half. And I've got minus 2/3 times minus 2, so it's going to be plus 4/3 e to the minus 2t. Okay, that's my acceleration. Now to find the force, I can use F equals ma. So it's going to be 6, which is the mass. It told me that in the question right back in the very start here. And then times a. And it also told us it was when t is 2 we were looking at. So we can substitute t into here. So it's going to be 6 times 3 over 2 times 2 to the minus a half plus 4/3 e to the minus 2 times 2. And again, I would type this whole expression to my calculator, use plenty of brackets so that it doesn't go wrong, and we get 6.51 newtons. That's our force there. So moving on to looking at vectors in calculus. So here is a vector for velocity. Here the velocity is given by t squared in the I direction, well that's horizontal, and the velocity is given by sine t in the y direction, or the j direction. What would be the acceleration? Well, we know that the acceleration is the velocity differentiated. So all we do is we differentiate the top and we differentiate the bottom. Okay, there's nothing more complicated to it. So t squared, when I differentiate that with respect to t, I get 2t. And when I differentiate sine t, I get cos t. And that would be my acceleration. Okay, nothing more complicated than that. If we are integrating it, one thing to bear in mind is, like obviously if we were going to integrate, maybe if we do the same one. So if we're integrating t squared sine t as a vector like this, integrate the top, so we would get 1/3 t cubed plus c. And the bottom sine integrates to minus cos t plus c. These two c's can be two different values. So you might want to call it c1 and c2, or you could just use two different letters. Okay, they're not necessarily the same value of c, because this value of c is relating to its displacement if I integrate velocity. So it's to do with its starting point. So its starting point might be like 3, 2. Okay, it's not necessarily going to be the same I and j component. So just bear that in mind. There's a few other bits of notation here that you might want to use. You might have seen before. We sometimes use r dot with a little dot above it for differentiating a vector, just to make it a bit shorter. And if we do the second differential, so the acceleration is a second differential of displacement, we could say r dot dot above it. It'd be like when we use dashes with f of x notation. So here's an example of using calculus and vectors together. So a particle of mass 0.8 is acted on by a force F. Relative to a fixed origin, the position vector is given by this expression here. So this says that r as a vector is given by 2t cubed I, so it's 2t cubed. I always prefer writing these as column vectors. 50t to the minus a half j. 50t to the minus 1/2. Okay, so that's its position. We've got to find first of all the speed, so the magnitude of the velocity at t equals 4. So the velocity is the displacement differentiated, so dr by dt. So we need to differentiate this. So I will get 6t squared, and then minus 25t to the minus 3 over 2. That's my velocity. And then when t is 4, I can just substitute that in. So I will get on the top, I'll get 96 when I type it in my calculator, and on the bottom I get minus 25 over 8. That's the velocity at that point in time. The speed, obviously we can just use Pythagoras, so 96 squared plus this value here squared, square rooted. And that gives me 96.1 meters per second. In part B, the acceleration as a vector when t is 2. So the acceleration, that is the velocity differentiated, the rate of change of velocity. So I need to differentiate this expression here again. So I'm going to get 12t on the top, and then minus 1.5 times minus 25, and then t to the minus 5 over 2, so reducing this power by 1. So that will give me 37.5t to the power of minus 5 over 2. Okay. Then substitute in t equals 2, and I get 24 on the top, and on the bottom the j component is 6.63 meters per second squared. For the last part, we've got to find the force when t is 2. So obviously going from kind of kinematics, acceleration, velocity and displacement, to a force, we need to use F equals ma. Now you will notice we've already got the mass of 0.8, and we're looking at the same point in time as we did before, so the acceleration is going to be this. So the force is just 0.8 times the acceleration. If we had to do it at a different point in time, we'd have to substitute a different number into here, but it's at exactly the same point, so I can just use this answer here. So 24, 6.63. So the force is 19.2 and about 5.30 newtons. There we are. So it's nothing really more complicated necessarily so far. It's just doing it to kind of two directions at once, really. So here's another example. So particle P is moving in a plane. At time t, the velocity is given by this expression here. So I'm just going to rewrite this. So the velocity is given by 3ti and then half t squared j. When t is 0, the position vector of P is 2 minus 3. So that's basically saying the initial position. Okay, so when t equals 0, the initial position is 2 minus 3. Okay. Find the position vector at time t. So we've got to go from velocity to position. So I'm going to integrate it. Okay. So I'm going to integrate my velocity vector with respect to time. So this will become 3 over 2 t squared, and then 1 over 6 t cubed. And now I need to do plus c. Remember I said before, these can be different constants. Now to find these constants, I can use this kind of coordinate here. So I could fill in 2 minus 3 as s and t equals 0. If I do that, because it's t equals 0, I'll actually just end up with c1, c2 equals 2 minus 3. So I can just say straight away here that actually s is 3 over 2 t squared plus 2. And then on the bottom we've got 1/6 t cubed minus 3. Okay. If it gave you something different to this, maybe it said when t is 2, this is a displacement, you'd have to substitute it in and work it out properly. But here it's quite nice and straightforward. Okay, this one. So this is a particle P is moving in a plane, so that at time t, its acceleration is 4I minus 2t. So let's just write that as a vector. So A is 4 and then minus 2t, like that. Now we're also told that when t equals 3, the velocity is 6I, so that's just 6, 0, and the position is 20 I and 3j, like that. Okay. It is useful when you're reading these questions to make these sort of notes, just kind of simplified so you don't have to scan through the question again. Now we've got to find the angle between the direction of motion of P and I, so the horizontal, when t is 2. Now when it says the direction of motion, so that's basically which way is it moving. So that we're interested in the velocity. Okay, that describes kind of how something is moving. So to go from acceleration to velocity, I need to integrate it. So the velocity is the integral of acceleration. So that will be 4t, and then it would be minus t squared. Okay. Then I also need to include my constants, so plus c1 and plus c2, like that. Now to find those constants, I can use this information I was given. So I'm told that when t was 3, v was 6, 0. So 6, 0 equals 4 times 3 plus c1 and minus 3 squared plus c2. Okay. So that tells me that c1 at 6 minus 12, so that's minus 6. And 0 plus 3 squared, so that's 9. Okay. So that means that my kind of final equation for the velocity is 4t minus 6 and negative t squared plus 9. Okay, that describes my velocity at any point in time. Now we've got to find the angle between the direction of motion of P when t is 2. So let's sub in t equals 2. So I get 4 times 2 minus 6, so that would give me 2. And then negative 2 squared, so that's minus 4 plus 9, that is 5. So that's the velocity at that point in time. Now I want the angle that it makes with I. So this means 2 across and 5 up, like that. And I want the angle that it forms. So it's moving like that. I want this angle here. This is the angle with I, isn't it? I is the horizontal. So I can do inverse tan of opposite over adjacent. And I get 68.2 degrees to I. And that would be my answer there. Okay, so putting together quite a few different skills there in that part. Okay, for part B, the distance of the particle from the origin when t is 0. So to get distance or displacement, we're going to need to integrate the velocity. Okay, so S is the integral of velocity, or the area under a VT graph. Gives you displacement, doesn't it? So we need to take this expression for V that we found earlier. We need to integrate it. So 4t integrated, that's going to give me 2t squared. Minus 6 integrated is minus 6t, and then plus a constant. Minus t squared, that's going to give me minus a third t cubed, and then plus 9t, and then plus c2. So that's my equation for displacement. I now need to use the information I was given at the start to work out these constants. So I was told that when t is 3, the displacement is 20i and 3j. Okay, so let's put that in. So the displacement was 20i, 3j, when t was 3. Okay, I'm just going to drop that here. Okay, so I've got 2 times 3 squared, minus 6 times 3, plus c1. Down the bottom, minus a third times 3 cubed, plus 9 times 3, plus c2. So if we use those, so the top equation, that gives me that c1 is 20, and the bottom equation tells me that c2 is minus 15, if we just solve both of those. So our full equation then for the displacement is 2t squared minus 6t plus 20, and on the bottom, minus a third t cubed plus 9t minus 15. Okay. Now the question actually asks the distance when t is 0. So when t is 0, the displacement is just going to be these two last bits, 20 minus 15. So that's the displacement, but I want the distance. So the distance is the magnitude of the displacement. So that's 20 squared plus 15 squared, square rooted, which is 25 meters. That's our final answer there. Okay, this is the kind of last example. So an object starts from the origin with velocity 2 minus 6, and after t seconds its acceleration is given by this. Find its displacement and its velocity at the moment when it is moving parallel to the vector 1, 0. So again, if we're interested in something moving in a particular direction, we are interested in its velocity. And we want its velocity to be parallel to 1, 0. Okay. So this bit here is basically saying its velocity needs to be parallel to 1, 0, so some multiple of 1, 0 like that. Okay. Now, all we're told is the acceleration. So we need to integrate the acceleration to get the velocity. So velocity is the integral of the acceleration. So it would be just t squared plus a constant. And then on the bottom we would have t squared minus t plus a different constant. Now to find what that constant is, you need to use some of the other information. So it says it starts, so obviously starts means t equals 0 from the origin, so that means that s is 0, 0, with velocity 2 minus 6. So we can substitute that in. But because it starts with t equals 0, we can actually just say that c1 is 2 and c2 is minus 6. Okay. So the velocity is t squared plus 2, and then t squared minus t minus 6. Now we've got to find out when is it moving parallel to 1, 0. So I can set the velocity equal to n times 1, 0. Okay, like that. So this means parallel to 1, 0. Now I've got an equation at the top. I'd have n equals t squared plus 2, and on the bottom I'd have 0 equals t squared minus t minus 6. Now the bottom is obviously easier to solve because I don't know what n is. So if I solve this equation, then I get t equals 3 or t equals minus 2. Well, in this case, it's obviously going to be t equals 3. So that is the point in time when it is moving parallel to 1, 0. And we've got to find the velocity at that moment. So the velocity at that point in time is going to be 3 squared plus 2. So I'm just substituting them into this. And 3 squared minus 3 minus 6. Okay, which gives me 11, 0. Just per second, and you can see that that's parallel to 1, 0 because look, it's 11 times 1, 0, isn't it? So that's the first bit of the answer. We've also then got to do the same thing but for the displacement and find at this point in time, so at t equals 3, what is its displacement? So to find its displacement, we can integrate the velocity. So when I integrate the velocity, where is it? There it is. I will get a third t cubed plus 2t plus a constant. Now on the bottom, I'll get a third t cubed minus half t squared minus 6t plus a different constant. Okay. Now to work out these constants, look back at the information we were given. We were told that when t is 0, the displacement is at the origin, so 0, 0. So actually c1 and c2 are both just 0. So obviously our equation is just this with these both 0. And then we want it at t equals 3. So we can then find s. So I'm going to have a third times 3 cubed plus 2 times 3. That is 15. And then do the same on the bottom, substitute in 3 into here. Now I'll get minus 13.5. And that is its displacement at that point in time. There we are. Okay, so there's lots of questions you can now do. There's quite a few different exercises. The way that they are split up is that exercise 8C is just about calculus in one dimension, so there's no actually any vectors involved there. So you could probably skip that one if you're happy. And then 8D and 8E about differentiating and integrating vectors, respectively. And I would probably choose to focus on the exam style questions. You might also want to do the mixed exercise 8 instead of any of these. If you're quite confident, you don't need to separate differentiating or integrating. You could have a look at mixed exercise 8, where it's obviously a mixture of the two.